So we have a colleague back in California, James Maloney, who's also been a part of the research project and one of the instructors in the project that you'll hear about today. So thank you CRLT, thank you SLAM, thank you DEI, thank you Rebuild, thank you all the folks at Michigan that we've been able to talk with. It's been a fantastic visit and we're really grateful to be here today. So Rachel, you did a great job introducing us. Just a little bit of context for Caltech. We started the Center for Teaching, Learning, and Outreach a couple of years ago. So we've been in startup mode and Skies has been in startup mode and it's been a really great partnership. We do have both higher ed level educational development under our umbrella. So we are working on course transformations and curriculum and working with our faculty and our graduate student instructors. And then we also have some K through 12 educational outreach under our umbrella. Do you want to say more about that?
Yeah, K through 12 has been great. We're such a small school at Caltech that we feel this is the way that we can really broaden our impact everywhere. And also, you know, when I'm not doing K through 12 outreach with CTLO, I'm developing Skies with my partner Victor. Yeah. So let's go ahead and jump straight to some of that.
And so those of you who have iPads or would like to install Skies, you can follow along, you can scroll back and forth, you can participate, and we'll give you some more instruction for how to do that as we go along. So a little context on this project, and we'll kind of lead you in to our process of data collection here. I think like many of you, we too are working on increasing student active engagement and active learning in classes. Like many of you, we also have a critical eye toward interventions that will really affect teaching practice, be sustainable, and have a good entry point for people no matter where they're starting the process of really thinking about changing instruction. And we love evidence. We like to think about how things are working as well as what the ultimate outcomes of them are. So Julius will tell you more about the app itself.
Great. And so many of you guys have iPads in front of you. So thank you for either using our iPads or bringing your own and installing the app. And so this app works, you know, pretty simply. It looks just like a regular PowerPoint. You know, I could, if I was in normal, you know, Sage in the stage mode, I would just be swiping, swiping, swiping. So every 2 minutes I would do this, and the hour would pass by, you know, uneventfully, unfitfully. But thankfully, we have some more interesting things going on. For one, you might start noticing that you can zoom in, you can zoom out, and you can start to see that instead of just a linear path, we have a lot of interesting side branches and tangents. And you can see we have some supplemental materials below. We have some prerequisite concepts on top. So you can go ahead and review things. You can sort of explore the tree while I'm talking, which is already kind of a neat thing. The other thing that's really neat about what we've developed, I think, is that normally the teacher, the instructor, the TAs might be the ones making all the material, and you guys would be passive recipients, you know, passive consumers of content. But this is not the case here. In fact, anyone can actually add to this tree in real time as we're talking. So this is more like a wiki. So let's go ahead and try this out now. Everyone can maybe go to this question card here. If you're in this presentation mode, please just go ahead and press the back button here to get back to this graph mode where you're able to zoom in and out. And I want everyone just to tap this question card once.
I only see 3 slides.
Oh, OK, I'm sorry. So I went ahead and switched groups on you guys without telling you. So if you're in this initial group here, just go ahead and swipe from the left edge. Just swipe like this, swipe to like this. Yep. And you can see all the groups. So these are the 6 sections we're going to be talking about today. This is the entire outline of our presentation. And everyone can just click the first one to go to background and approach. This is the group we're currently in. Is everyone in that group now? Yep. Background and approach?
Great.
OK, great. And these are also sort of our learning objectives you can see on the side. So it's sort of an outline of how we're going to proceed. So if you just go ahead and touch this card, you're going to see 2 green arrows, one above and one below. Just take the one on the bottom and drag it to an empty space in your screen, like this, and let go. Just go ahead and let go. And you're just going to see all these choices for types of cards you can make. Just press answer. Since we asked the question, you can provide an answer. And now you can go ahead and introduce yourself, and maybe type in something about how your students use tablet technology in their classroom, if at all. So I'm going to go ahead and type in, hi, I'm Julius, and I work introduce yourself and write something about how your students might be using tablets in the classroom. And I work on science outreach. Now, another cool thing that you can do is, you see the little speaker icon, the one that looks like the little Hollywood sign? Just go ahead and tap that. And you can see all these multimedia things you can put into each card. So I'm going to go ahead, you can put pictures, sounds, drawings, equations, web references, things like that. I'm just going to go ahead and put a picture. And now it's selfie time. So I'm here, and you guys are going to be up here too. And I'm going to press post. So you can see I've been added to the tree. And if you hit refresh on the upper right-hand corner here, you can see everyone else's contributions as well. I see Thomas has added something. I'm going to wait here until every single iPad gets back to me, okay? No, really, I'm just going to wait another minute. One last refresh. And now the thing is, you see all these contributions coming from this room. You can imagine how this might get unwieldy after a while. The tree gets kind of big. So you see the little X button here. You press the X button, everything collapses down. And so this allows us to structure our knowledge tree such that, oh, okay. So let's see, hello, is it me that you're looking for? Maybe not. Let's see, Rana and Mary, welcome. Glenn, learning analytics and research work. Excellent, we've been talking to so many learning analytics people here. This is not a selfie, this is a me-e or a us-y or something that's not a selfie.
A you-e.
Photo. Perry, lecture tools, we love, I've read all about it, it's great. Stephanie and Robin, no tablets yet, but maybe soon, who knows. Dan, Self-Efficacy Studies, no tablets either. Adam, GSI, no laptops allowed. That's great. We have a West group, we have a technology work group, and we're going to invite someone who's against technology. We're going to have a no technology talk. It'll be great. Pujam, Facebook. Well, of course, yeah, Facebook. Facebook's popular. Phil and Melissa, tablets, great. And me, and then Jared here. And using notes right over cards, also a great application of tablet technology. And so you can see the sort of way we've used it in our classes at Caltech. This is just an example. The teacher might start with a thread of cards that they create, their own lecture slides, and students will start to add their own material to it. On top of the lecture materials, they'll add their own notes, add their own explanations, they'll add quiz questions, they'll add all sorts of reference materials for each other, which is kind of a neat thing to have. In addition, so you can see, in presentation mode, you can see all the student contributions piling up below. You can see that you can have discussions. One student can post a question, another can branch off an answer. You can go sort of back and forth. You get a lot of really cool discussions happening as they branch off in real time during class and after class as well. You can go ahead and make quizzes. You can make quizzes for the students. Even more remarkably, we see students making quizzes for each other. So it helps reinforce learning. You can make a flashcard, but now instead of the flashcard just benefiting you, it benefits everyone in the class. And once they see it, they start adding more. It becomes a real snowball effect. You can write notes. Notes are great. Anyone can write notes, but now anyone can see each other's notes too. You can freely share notes. And so students can sort of gang up on the lecturer and just start posting notes everywhere to make sure everything's well covered. And we'll talk more about that later. Students can also rate cards. I can simply go ahead and touch this card and rate it on a scale from 1 to 5. Let me see if I understand it. Okay, I got it. And what happens is after you collect all these card ratings, you can zoom out and you can see which ones they understood, which ones they did. Hotspots appear. And you can get really actionable real-time analytics that's really easy to access in this sort of zoomed out format. And teachers can use it to inform their teaching practice. And of course, you might imagine we've worked with CTLO to investigate all sorts of research questions.
Yeah, so Julius promised he would operate this because I've done less live teaching with it. I've been more looking behind the scenes. Thank you. So we had some general questions as we saw this technology being implemented in some of the early classes about how students would participate, what might we find out about in-class engagement, the kind of real-time moment-to-moment work that students are doing, and then what might motivate faculty, what might motivate students to participate in a space like that. And then we're very interested in the kind of durable record that through through the technology we might have access to that is also visible to students and to faculty. So we have made those into some slightly more formal research questions. We're looking at some observable patterns in real-time engagement during class under some different conditions, which we'll talk about, different kinds of teaching environments. We're looking at types and levels of complexity in the student engagement itself, in the content, in the format, in the choices that students make and how they participate. And then we're actually very interested in the relationships between student engagement, learning, and the motivations of faculty and students alike. And thinking about that, how do we sustain changes in educational practice over the longer term? So we, through this study of several of the classes where this has been implemented, got some qualitative data from students. So we asked them about their experience through surveys. And we also have a whole lot, for us anyway. It's not quite big data, but it's pretty big data. It's medium data. Medium data is the term of the day. It's like, yeah, orange is the new black, medium data is the new big data. Quantitative data from the app, and really what we've been fascinated with in large part is this moment-to-moment kind of information about how students are participating. So a little bit about our context at Caltech. Like CRLT, our CTLO has been involved in helping to coordinate the project and also manage the research and data collection part of it. Of course, Skies has been there with the app, but also with some hands-on support in the classroom itself. And then our Provost Innovation and Education Fund has helped us have a pool of iPads that are dedicated to a particular class at Caltech, and similarly at Pasadena City College, which is our community college partner in this project. They have also a pool of iPads that are dedicated to certain classes. So in this study, we had 3 different classes, and interestingly, they varied in terms of the degree of structure and of change in teaching practice. So you can think about structure as how directed students are in terms of their use of the app and the kinds of active engagement that they participate in. So there's some, if you're exploring in the app, you can read the more formal definitions down below, but our low structure case, which is a upper level undergraduate genetics course, really the faculty member didn't change much about how the lecture worked. So he's been using PowerPoint slides for some time. Those PowerPoints became the main thread in Skies for each class period. And through some modeling of the TAs, students were free to participate in any way that they wanted. And you'll see a little bit later that some of them really got into it and added a lot of material to the app. And was an interesting thing happened in that case. Our medium structure case is a chemistry lab, largely for freshmen, one that is an alternative to the main chem lab focused on energy production chemistry or solar chemistry. And in that case, the lecture material similarly formed the backbone in the Skies tree, and students were encouraged to participate in a kind of open format, but at times they were directed to add a particular kind of information, an answer to a question, or information that would pertain to their pre-lab or post-lab, but relatively minimally directed to do that on their own. And then our high structure cases were calculus classes at Pasadena City College, where the faculty member took time out of class, gave students specific prompts to branch off from the Skies tree, and they were asked to, for example, solve a problem right there with their table mates or with someone nearby, and maybe post a photo of a part of their solution or a part of their problem-solving process. And then in real time in the class, that material was looked at together.
Great. So let's go on to the next section, section 2. So we're going to talk next about participation inventory, literally just counting up cards. So, okay, so we all know how to count cards here, right? Count Skies cards. So the first off is if you actually ask the students how to use Skies, you'll notice that, in terms of the gradation between passive learning and active learning, what do all of our students prefer? Sitting there, yeah, they love sitting there, they love browsing, they like opening things up and down, up and down. But in terms of actually making cards, using cards, it tends to be a smaller group of students. But the ones who do are often the most participatory, very fervent about adding lots of materials for other students. And so this is what we notice from the app, and this is what we notice from the self-reported data as well. Taking that into account, that this doesn't reflect uniform participation, but just a subset making a lot of cards, we might ask how many cards get added in, let's say, the genetics class. The one that's low structure, sort of a free-for-all wiki. Professor says, I'm just going to go do my thing, but you guys can do whatever you want. Just take it into your own hands. What ends up happening? Well, what ends up happening is in the first year, 843 cards get added to his existing 840. Basically, it doubles in size. For every slide the professor makes, on average, the students and TAs create one additional card, which is sort of neat. You take something, put it into the ground, it doubles in size. Next year, what happens? Even more cards get added. And because everything's cumulative, now it triples in size. So from an initial seed that you plant in the ground, you get this rich branching structure with who knows what sort of content, interesting content. OK, who makes the cards? In the first year, it was largely directed by the TAs. The TAs were setting the example. They were adding their own comments, questions, notes, things like this for the students. And the students were kind of curiously on the side, that looks kind of neat. Let me add something of my own. In the second year, the situation completely flipped. Now the TAs were adding less cards, and the students took over making most of the content. And by year 3, which we don't show the data here, it's almost entirely driven by the students now. They're the ones creating, driving, branching off the entire process. And so we might ask, this was the low structure case, okay? Completely free-for-all, wiki style. You guys can do whatever you want. How do you guys think the degree of structuring in the class might affect the level of participation, just in terms of the number of cards added? So here we have a clicker style question, a matching kind of question. You guys can go ahead and drag and make a prediction here. Just go ahead and drag, make a prediction. And once you made your prediction, hit submit. I'm going to give you guys 30 seconds, and then we're going to go ahead and collect the results. So Skies is also a great clicker.
This is kind of a matchy-matchy, so just touch your finger on one on the left and drag it, keep it down, and then drag it to the right. Oops.
OK, let's see what you guys all said. So I'm going to hit the analytics button here. Wow. OK, four of you guys answered. And it looks like no one got it right, which is great, because we have a surprising result. A surprising result is the essence of science and research. And so, in fact, let me try to answer my own question here. I'm going to say, because I know the answer, the most cards were made when there were, let's see, maybe high structure, then low structure, medium structure. Yes, I got it right. OK. So as you might imagine, or I imagine, here's why. Here's why, OK? Let's see. What we found is normalized to the amount of cards that the faculty made. In the calculus class, a lot of people participated, just because it was mandated. Every 20 minutes or so, they'd say, work out a problem. We got a lot of people participating from all over the class. In the case of genetics, it was a few students participating a lot. OK, does this make sense to you guys? In the low structure case, there's no requirement, but some students get really into it. And so you can see this distribution here. In the low structure case, there were students who made hundreds of cards, 250 cards, 220 cards. But then it died off kind of quickly, because everyone else was like, oh, this is great. Someone else is taking notes for me. Someone else is making questions for me. Sometimes they would take an exam, feel guilty, be like, oh, I got all this great content. Let me make some more. And then you'd see a little bump, and we'd see all sorts of interesting patterns. But for the most part, card creation was driven by like 5 or 6 students in the class of 25. Yes?
Sorry, so this is a few students at the student number axis. So this is how many students added?
How many cards per student? Each
Yes.
bin is one student.
Each bin is one student.
Yeah.
Okay.
So literally, you can see how many students are adding cards in this case. In the high structure case, you can see more cards actually got made. So before it was 500-something cards. In this class, 700 cards were made. But you can see the distribution is more even over the rest of the class, because it's mandated. Everyone's participating some, everyone's participating some, et cetera. So there's still a discrepancy. There's still some fall off, but it's a more slow decay. In the medium structure class, what ended up happening was it wasn't required. It was slightly encouraged, to the point that I don't think the students quite knew what to do. I think the ones who were really fervent were like, but he didn't really tell us to do this. The ones who would have otherwise done it if they were forced to, weren't forced to. So we got sort of a trow. But it turns out if you go to either one of these two extremes, you're very clear about what you expect from the students, then participation takes off like crazy. And so that's pretty much our conclusions for this section. either you say free for all, you guys take over, or you say do this, do this, do this, but you just have to be clear about what you expect. And of course, you get different patterns of participation. Yes, question.
I'm sorry, but back a few slides where you showed the results as I guess the instructor, go back one more, I think, back one more. And you showed results and said we didn't get it, but how'd you know that?
Which one?
Oh, can you
The
show the
analytics.
analytics on that?
Analytics,
Just
yes.
open up your view of the analytics
Oh.
on that question
particular
card.
slide.
Yeah. So there's a button up in the corner that gives him a real-time view of what's been submitted.
And so you can see that 7 people did not get the correct answer. 1 person got the correct answer. And you can actually see the distribution over what people said. It's sort of hard to summarize a matching card in these sort of histograms, but we do have it, yes.
I'm confused because I think you're confounding 2 variables.
Okay.
And one is structure, and the other appears to be mandated versus voluntary participation. So the high structure case is the one where the use was mandated, and the low structure was where it wasn't.
Yes.
In our case, the low structure was both unmandated and left free to student choice. So we do have 2 variables in there. They just happen to be going together in the same way. So we haven't made an effort to separate those out in these instructional cases, largely because these instructional cases where our faculty are going to do what they're going to do, and we can kind of capture it and try to understand it. Yeah.
Well, as a follow-up, the professor who did the low structure case was intrigued to see what happened if he did make the students participate. So he did do the confound. He tried to separate out these variables by saying, okay, you guys can still do whatever you want, but it's going to count for part of your grade. So the students are like, So what do you think? What do you think the histogram looked like then?
Well, I think it looks like when faculty have these discussion boards or postings,
Yeah.
and sometimes when you mandate their use, you'll get a pattern that looks, I think, like the pattern you have here. Everybody will do some, but some students, the better students maybe, will do more, right? The ones who want the A are going to do more than the people who are happier with the B or the C.
Yeah.
Sure.
So we actually got something that looks exactly like the sum of these 2 graphs. We got a nice long tail, broad participation, but we still got this nice spike of some really fervent students going, I don't know how he's grading this, but I really like this, and putting in a lot of content.
Well, that's a
Absolutely.
huge point. I'm sorry, but how do you
Yes.
do assessment now? Because
Yeah.
quantity is one thing, but quality, I was comments, is going to be hard to grade. So how do you
Right.
do that?
Well, in this case, we were pretty generous with it. We just said whoever's participating, gets the participation points. We didn't try to quantify it. We figured it was more for their own benefit, their own sort of, as long as you're adding something, contributing to the discussion, we feel that it's okay. But that would be a really interesting question, right? Because we could do upvoting, we could do peer assessment, we got the professor highlight certain cards, we could award prizes. We've experimented a little bit with that, but not extensively. But that would be a really cool direction to go down. Yes?
I'm curious about, it sort of goes to this quality control and also the extent to which this becomes overwhelming potentially for students or instructors. So you can have any number of cards, they can have any number of correct, incorrect, partially correct
Moderation.
Yeah.
assumptions. And as well as that, if there are 20, 50, 80, 100 cards,
Yep.
what do I, as an instructor, do with that, and what do students do with it? So is it a production mode, or is there a reception mode as well?
Absolutely. We've built moderation and integrated feedback and this sort of thing in the app. So we have several features for that. The first is only the instructor can be adding along the main path. So the main path is authoritative content dictated, this is the class path. And what you can do that's really interesting as the instructor is, if you see any interesting contributions down here, you can actually just drag it up to the main path and promote it. You can say, okay, you've contributed the cool question, you've contributed the cool question. Let's go ahead and promote these contributions up so the rest of the class can see them. And now it's very visibly on the main path. The other thing is, as you're going through this big stack of cards, you might imagine you get a lot of contributions here. And it's hard to do because I don't have a stack of cards right now. Let's say you have 10 contributions, and you go through them and you say, okay, this one's cool, this one's neat, this one's neat. You can just go ahead and highlight it. You can promote it. And any highlighted card appears in the top of the stack now. Just like you have a bulletin board, you can promote, you can pin discussions up, you can do the same thing with these cards. So you can see what the noteworthy cards are. And this is a really strong incentive. Beyond points, beyond any sort of metric, students really like seeing their work showcased, promoted, talked about by the instructor. And so that by itself It's like you submit a paper to a journal. You want it featured. You want it on the front page. This by itself becomes something that the students really engage with.
Let's move on to the next section, and we'll then save some time for questions at the end as well.
Oh, we have a participation question here. Should we go ahead and do it, or skip on to the next
I
one?
would say we should maybe
should
move
skip
on,
on.
and we'll do some more participation in the next round.
You guys had your chance of participation. You took it. Okay, next section. Let's go on to the next section. But actually, it was fun because that discussion we had was exactly the question we were asking.
Yeah.
Do we want participation from everyone? Is it actually helpful? Yes. Okay, behavior in time. So this is another sort of metric we can get once we start talking about real micro data, in-class engagement data. What does this actually look like? And so one question was, well, what does it look like when students are creating cards and adding knowledge, contributing knowledge to a class in real time? What does that look like? And so we sped it up. We don't want to take you guys to be sitting here an hour and a half. But this is what happens over a 90-minute class. You can see students are adding cards like crazy. They're adding, they're contributing, they're branching off each other. And you can see it following the flow of the lecture. As lectures are coming, you can see questions being made, quiz cards, flashcards, notes, and they just flash by, flash by, flash by. And literally, you can see this unfold before your eyes. It was funny. I don't want to go on too many tangents, but Cassandra and I, we were sitting in the back of the class. We were watching students. They had laptops, they had iPads. The ones with laptops were sort of getting a little distracted. Maybe a little distracted. Maybe they were going on Amazon. They were purchasing some items for themselves or for their partner. There was someone who actually watched the entire football game on YouTube. It was heroic. He had headphones on. He was going through. But the ones who had Skies, the ones who were using their iPads and engaging and contributing and actively learning, they stayed on Skies the entire time, straight through. They were making cards. They were focused. They were engaged. And so this is something that can really keep students' attention for a long period of time because it's flexible. Anyway, I'm just going to stop tooting, toot, toot, and you can look at the zoomed out view. And this is, again, you can see students just adding as this class continues on. Okay. So we go, okay, what are the sort of simplest things we can study just by looking at timestamps? Nothing else. No card content, just looking at timestamps. You can see they make cards steadily throughout the term. You can see that there's actually a little bit of a learning curve. Collectively, the entire class takes about 2.6 hours at a rate of 33 cards per hour. But then they ramp up. They ramp up production to 44 cards per hour once they get the hang of it. It's pretty steady state. It's pretty good going. And then we start to ask another question. Okay, this is the collective rate. This is collectively how long it's taking students to make cards. They've gotten into it. But what do the micro patterns? Is it bursty? Do the students tend to make cards all at once? How does the attention ebb and flow in the context of a class? This is something we can actually get without any classroom observation. I didn't have to go into the class. I didn't have to sit in. I just sat in the from my computer and just did some data analysis. And you can imagine, what would it look like if a model student was creating cards? Let's say the student was always paying attention at a uniform level. And you always had the same inclination to make card moment by moment. You had no memory of what had just happened. You had no memory of what happened a minute ago, an hour ago. All you were doing was saying, at this moment, do I feel like making a card? And maybe in this moment in time, there's a 1% chance I'm going to make a card. Moment in time, 1% chance. And those of you who are math and physics and whatnot, you're like, oh, this is a Poisson process, of course, exponential decay. And this is exactly how it's going to look. Well, is this in fact what happens if you look at individual students? Do you get this sort of process? Can you fit it to that sort of statistics? And the answer is, maybe, maybe not. TAs are more like these model students. They're always on. They're always willing to make cards. Not much of a lag. But most students, you observe their card-making behavior. You see there's a lag time. There's a refractory period from when they just made a card and they're like, you know what? I'm good for now. I'm good for a minute. I'm good for a while. Let me just sit and rest and look at other contributions and maybe browse and do. Okay, I'll make another card now. And then they do it. And then you notice there's sort of a lag time, this sort of refractory period. But then you might say, what does the entire class collectively look like if you have like 3 or 4 people working together? What does this look like if we add everyone's contributions together? Now you get a model student. Now you get a Poisson distribution. Now, this isn't an entirely surprising result. There's a mathematical theorem, in fact, that says if you add a lot of these independent stationary sort of processes together, you're going to get this sort of distribution. But what was surprising to us is even with 3 or 4 students at most contributing at a time, you can get this sort of distribution. which leads to another aspect of collaborative learning. Of course it's good for learning. Of course it's good for students to talk to each other. Of course think, pair, share is good, and you're doing all these intermeshing knowledge and doing all these things, but even in the extent of communication just through the app, just through this way, you're getting this sort of neat effect where at any moment in time, individual students might not be paying attention. You might only have one person's attention, one person's attention, one person's attention. But collectively, the entire class is with it, always on, always taking notes, always ready to make a card. And so you get a rich array of notes and cards and things like that. And it was great because sometimes I was in class helping to make notes, and I might miss something. I'd be like, OK, I'm pretty good, I'm pretty good. And I would look back and notice all these things that I had missed that the other students had filled in for me. So by making it more like a wiki, by making note-taking even more of a collaborative process, you get all sorts of, you fill in everything. It's a really neat process. OK, so here's my question. How might we change lessons to benefit students even if they're not all paying attention at the same time? So you guys, give you 2 minutes, and let's see. Wow, OK. So a lot of great comments for everything from crowdsourcing, how important content bits are. You can create review forms. You can benefit. So again, take into account these collective student properties, all these contributions that are collaborative. That's great. Another idea is to incentivize participation and also the peer assessment. So students can be upvoting each other's cards. That's also a great way to filter it. Outsource it to the class. Why do we have to do all the work? So as more we have students do, the better it is. Catching up, reviewable record, absolutely. Review is a great, students really like being able to go through and look at the comments, and they don't have to do all this in class. They can do a lot of this outside of class as well. We've experimented with a lot of that as well. Paying attention, students' good notes. You can look at notes. This is sort of a record for what's going on inside the class. Keep in mind, I'm responding to these in real time, so maybe I might not be reading these comments in exactly the best way, but I can review them later and go, OK, that's what they meant. So there's something good about that too. Period to review, comment, reflect. Yes, we've been trying to, and this has been changing instructor practice. And Cassandra will talk more about how people have been putting in more positive or reflective periods into this. More time frames, response. Yes, you guys are noticing the multitasking can be tricky. If only there were a way we could incorporate reflective periods into the class discussion. And yes, instructors have started to do this as well. And this is the ultimate goal. OK, Cassandra.
Thank you. Then we didn't have to say it. We appreciate that. So as we were having a little side conversation. Oh, sorry. Go ahead, Matt.
So I was just wondering, do you have any sense of how this process has affected student note-taking?
That's a really good question. We haven't studied that formally, but it's certainly something that we could look at in the future. Yeah.
And they weren't really taking notes before, was our observation. So this was helping a pretty bad situation already.
And I think largely in a class where it's a lot of PowerPoint slides, sometimes the sense is like I already have the information. I don't need to annotate it. I don't need to add on to it because it's all there. But of course, that's a really different mode to be participating in or not participating in. I'm
sorry, but
yeah.
I hate work. And you said
What'd you say? You hate work?
I hate work.
OK.
After class, I'm going to go back and review all these notes. Sounds like work to me. So is there some summary that you can provide then and would make it easier?
I think it depends on the kind of input that you're asking from for class. So there are some really nice views that will capture at a glance the kind of clicker style or quantitative input or student ratings of cards. When we ask for something qualitative, then we're going to have to review it. But like a minute paper takes maybe a few minutes even for a stack of 100. You kind of flip through and look for the themes. It's a similar kind of process here when you're looking for those qualitative kinds of responses that you might flip through. A few are going to stand out that you might highlight and pull up to the main track or just put greater student attention on those. Yeah. So we had a little sidebar conversation about the kind of data that we've been looking at, which is largely the most participatory, most active form of creation of card content. We were also curious about more the modes of contribution and the differences between levels of card creation, but also different forms of participation. And then if we looked at the content of those, which as a small-scale research project, we were able to do what those would look like in terms of different cognitive complexity. So we took the genetics class, which was earlier on. We've had a little bit more time to look at that data and did some of this work. So first of all, one easy way to break this down is by cards that are just information and cards that are questions, that are some form of self-assessment that students are posing either to themselves or to each other. And you can see here quite clearly that in this class, students prefer to just stick with the information, to stick with the facts, and the TAs were a little more prone to asking questions, to prompting thinking through assessment type questions. There's a little sidebar up here. I know you have graduate student instructors, we have teaching assistants, and this is a little sidebar about their role at Caltech. So the other thing that we noticed about TAs when we looked at the analytics on the cards themselves is that they use more words, they tend to be more verbose, they have more to say in general. So 32 words on average versus about 20 words. But we took it a step further and worked with a small group of former TAs for this class so that they had some expert content knowledge in the area and simplified a coding scheme according to a very, very, very rough and simplified Bloom's taxonomy. So we split our informational, our note cards into facts, those that contained some summary and synthesis, and those that went beyond to some like new insight that really wasn't yet part of the class. And then different levels of questions, pretty rough breakdown between questions that were really strictly recall and those that required some form of thinking, synthesis, that kind of thing to answer. And then other ones that were sort of open-ended, maybe not quite related to the topic, but more curiosity type questions. And then there were some cards that were something else entirely, which were really delightful to see because often they were bits of humor, inside jokes about the class, little things that the professor said that got replicated and were really interesting to see. So with this group of TAs, we had them code. We took a third of the coded set and coded it again. So we did some inter-rater reliability. It's pretty dry stuff, but it turned out okay as inter-rater reliability goes. The coded set of cards really looked like the whole set of cards, although it was only about, I think, about half of it. So 60% TAs, 40% students. So it was a pretty representative set. So you can see that students, as we might have predicted, lean a little more toward the factual type information in their notes and far fewer questions as we saw before, but also less synthesis and summary and insight. TAs, on the other hand, much more synthesis and a lot more questions than students. But what's really interesting for us to take a step back and think about is what this whole set of material looks like together and the ways in which our different instructional and learning roles in the classroom were complementing one another to give us overall a pretty balanced set of material for students to study with and from. So interestingly, we feel a little bit of a kind of a knock-on effect that the group participation is kind of benefiting the individuals almost not necessarily regardless of, but across the range of their individual participation. It was still giving them a richer set of material to work with and to study from. Good question?
So you described the structure expectations for the students. What were the structure expectations for the TAs in these various courses? And were they tasked with, as I give my lecture, you are going to pose questions at any given time, or was it completely open-ended? So what was the instructional understanding for the TA role?
So in this class, pretty open-ended. Like, their expectation was that they would be participating and adding, but what they added was really up to them. Yeah. So that the asking questions was not prescribed in this case. So we also looked at these different types of cards, different levels of cognitive complexity, and how long their creation took. And so perhaps a little bit interestingly, but maybe also slightly expected, if you look at the red or the pink cards, the factual cards took a little less time to complete on average since their last contribution. And then the question cards took less time even still. And we're not entirely sure why that's the case, but the question cards did tend to be a little shorter. They were less wordy, less information in the card. But also they were made more by TAs. So either of those factors might be at play or both of them, and we weren't able to separate that out.
For the student submissions, do we know which ones were mandated and which ones were voluntary?
This is the case where all of them are voluntary. So this is just one of those instructional cases. Yes. Yeah.
So it's also sampling a smaller set of students, those that participated a lot.
Yes. Yeah. Yeah. These are really driven a lot by the high participators and then some by the rest of the class. Correct. So a little bit of a summary, differing in types and complexity. It takes longer to do some things, but this overall effect seems to create an environment that's pretty rich for learning. Yes?
So I guess I'm a little bit disconcerted by the characterization of making cards as active participation.
Okay.
And so if we follow that through, does that mean that in this class, people stop raising their hands, they stop turning to the person next to them? I mean,
No. And so in this class, they were not turning to the people next to them before this instructional change happened. However, you'll hear from the faculty in the next section that they then did a lot more of that as their engagement actually in the app increased.
Okay.
Yeah. So quick participation question. How are we doing? Good. Yeah? Do we have until about a little bit after?
A quarter after.
Okay, great. So we're curious about your responses about how classroom teaching might change when it has this visible element of collaboration that both students and faculty can see. And Julius will do the timer.
I'll do the timer.
You can also turn to your neighbor and discuss if you'd like to do that before putting in an answer.
Let's see what you guys say. Oh,
Can I peek?
Yes. You just hit down to.
Great, so multiple answer. Yeah, do they receive credit for participating? If so, will it increase? And although the case that we analyzed in more qualitative detail was this open participation case, again, some of our other cases have given small increments of participation credit or asked students as part of a structured assignment to participate in this way. Yeah, so interaction with other people across the year. Interestingly, so how do students model for each other? How does the environment become one that they want to participate in? And certainly seeing each other. Yeah, and it very much depends. I think our faculty who are continuing with this app and this use are really changing how they message about it, how they talk to students at the beginning of the term about the potential benefits for them, about the reasons that they're using this technology, about what they hope for students. Yeah.
Do a majority of the faculty that use it stick with it, or what is?
Yes, so far they have. They've wanted to, and we have actually more that would like to be using it than we can currently support. So that's an exciting place to be in.
But some are not following through with it, or everyone is?
No, they've all followed through. Yeah, they've all followed through. More breathing room in the delivered content to empower the collective to fill the void. And that's actually what more of our faculty are starting to do, to leave spaces in the class. So they're starting, I think, to trust a little bit more that students will fill in some of these ideas, that they'll be able to make the connections, and kind of opening room up in class for more of the live interaction to happen. Stronger sense of community. Yeah, we're going to hear some faculty voices in the next section. Definitely more dynamic. Our faculty noticed that as well. More pressure for less engaged students. So there's a kind of norm maybe in the class that the normal thing might be to participate. More points of view getting into the discussion. And in fact, those who might not speak up, we have a lot of ways for those who might not feel as comfortable getting their voice out into class. Yes, and that one too, same thing, similar thing. And more responsibility, over learning and teachers losing some control, which is always a scary thing. Yeah, Mary.
Can I ask a question about that last comment? So
Sure.
Robin Fowler over there
Yeah.
has done a study looking at differences in team collaboration when it happens online
Okay.
versus in person, and found that there's more equitable participation when it's online.
Huh.
And I'm wondering if you've done any analysis of participation by gender showing a similar dynamic.
No, we haven't looked at that, but that would be fascinating.
And in K through 12, we've noticed that the teachers have told us, a lot of teachers say English language learners speak up a lot more through the app than they would normally in person. So they see a lot more participation from underrepresented groups.
I'm wondering if you have a way to identify which collaboration patterns is good, which one is bad. I guess it's not every collaboration pattern is good, right? It's sometimes that they may seem to collaborate, but they may talk about something else, not the learning that we are expecting.
Right. The app doesn't necessarily tell us that, but in the high instructional structure case, student groups were posting information. So we can certainly ask our colleague what their anecdotal observations were like in the class. But there was more of a trace of what the groups were doing than if you didn't have any visibility, because they did share their results. Yeah.
Do you have any sense of if peer pressure encourages wider participation in the class, does that result in any sort of measurable improvement in the outcomes?
Let's look at measurable improvement in some outcomes. So we wanted to tell you a little bit about some of those outcomes, but also really what folks were observing. So just a little bit about encouragement and rewards. In that, especially in that low structure case that we've talked about, or where faculty weren't giving credit, we just wanted to let you know that there was still encouragement. So there were messages sent to students, some statements made in class, little rewards like a little Jamba Juice, gift card for participators. Julius made
only the best ones.
Some certificates for them, and then in our high structure case, they were getting a tiny fraction of participation credit for engaging in this way. So these are really pretty small extrinsic rewards, and not things that would actually really change their grades or outcomes. We asked students what at the end why they reported using skies, what benefit it was to them. And interestingly, at the end of the terms, and this is all students from all of the classes in rank order of their responses, which were pretty consistent across the different classes, students identified the intrinsic benefits to them, to their access to materials, to their learning, to improved studying, to the engaging time in class, and to their own focus as the most important things for them in using the app. And really didn't value at the end. Now, those little rewards might have helped them get over the hurdle to start participating, but in the end, they recognized the value to their learning as more important. Quick multiple choice, if you want to take 10 seconds and enter. Do you think your students are more extrinsically motivated, intrinsically, or maybe not at all motivated? So if you want to do a quick entry there, I'll just give you about 20 seconds.
Wow, you guys think they're all intrinsic.
Oh, that's fantastic.
Great. Ours too.
Ours too, everyone, all intrinsically motivated. So the faculty observing and reflecting on their experience really saw people get drawn into the conversation live in class. They felt that they were getting more verbal questions as well as insight into what students were thinking and wondering through the app, and really kind of saw ownership change in the class, whereas students had been a little bit disengaged from the creation process, that they were part of the creation of the content of class, and the faculty really appreciated that change in tone and timbre. And really shockingly, in one of our classes in particular, in the genetics class, the overall grades improved dramatically. The faculty member here was shocked and said a little bit embarrassed, perhaps at the idea that they had thought that the students were doing as well as they possibly could, and yet here was some evidence that they could do better. This particular course has been taught in a very, very consistent way for over a decade, and here's just the three last years. The average end scores for the whole class were in the 80s with extra credit. The first year that this was implemented in the class, it went up to almost 100. You can see why the faculty member felt like, whoa, what just happened? That gain persisted, but they took away the extra credit. Somebody say something about grade penalties in STEM classes, maybe, that we've been learning about from some of you, to bring it back down, but it's still a significantly higher grade than before on, again, very consistent kinds of assessments.
It actually includes credit given to them, extra credit given to them for participating in the SKY.
No.
Oh.
For other work in the class, not for SKYs.
Oh, okay.
Correct. Yeah. Yes, lots of questions. Okay.
So that 98 also includes the credit they're getting for the actual participation in that.
No, so in this case, no credit has yet been given by this instructor ever for using Skies. Yeah.
So you said it was significantly increased, and I'm wondering if using significantly in the formal sense, did you do a test of significance?
So the faculty member, I believe, did, but we can check back with him. Yeah, so he did the analysis on the grades himself.
So the extra credit, the same extra credit was available in the previous years, 9, 10, 11?
Correct,
Okay.
correct. Yeah, and do you know what the form of extra credit was? It like an extra?
Yeah, students could do like extra projects. They could drop the lowest homework grade, stuff like that. But generally, extra
was
work
the same.
would be to boost their grade.
Yeah, but consistent. So students also talked about the benefits to themselves. They talked about engagement, about being able to manipulate things during lecture, check back, look forward, supplementing what was there with alternative explanations, made it interactive and fun, repetition and study and practice as well. So we're curious to hear from you. I think this is our last interactive question. What sort of incentive you provide or could you imagine providing for students to engage in collaborative activities? So we're certainly seeing some benefit to students, and we're really intrigued by these kind of actionable analytics that are over time seeming to change some instructor practices. And interestingly, we're calling this a kind of gateway drug to thinking about teaching transformation because we've seen a kind of progress happen with really the most minimal change that, that we can really kind of imagine on the part of a faculty member, but yet the data coming back is giving them some insights about what they might do next. We're now thinking about how to look at self-efficacy for students. So we're asking some questions this year about students' perceived ability to be successful with respect to technology, with respect to content, and with respect to their overall student experience. We're also working more closely with teaching assistants and trying to understand their role in changing teaching practices and also this kind of immediate access to analytics by faculty, by TAs, and by other students as well. We've been trying some synthesis of the analytic data as well as qualitative observation. So we've provided a weekly engagement report, and we're looking at how that might be helpful for a case like this where there's change happening, there's a lot of data, and helping to synthesize that regularly. So Skies has been spreading. We talked about the 3 classes that we have looked at so far. This year, actually, that was prior. We've also used this in a machine learning class in conjunction with a MOOC and in other computational and theoretical chemistry classes. And this year, even more classes were interested in this, so faculty are also talking to each other and spreading the word a little bit along the way. So for the future,
yeah, no, it's been great. We've had all these conversations about scaling and things like that we haven't had to have before, but it's all in a good sense, like DEI. We're trying to take an innovation, scale it out. Even more ahead, we have the ability to link not only cards within classes, but also between classes. So you can see, for example, we have this card of d orbitals here, and we can jump almost immediately. We can jump immediately to the chemistry class that contains this card.
Wi-Fi permitting.
Wi-Fi permitting, and then we can jump right back to the thing. So we can create these tunnels between classes. Students can peek at each other's things. You can hyperlink things together. So that's really exciting for us. So we really want to start tying courses together. All our core classes, we want to be able to interlink, which will be great. Going from one topic, advanced topics, basic topics, prerequisites, all that stuff. And of course, I see you guys all know what's coming next. Once we're able to interlink classes to a unified whole, break down those silos, we can start to create really large-scale analytics possibilities. Create a GPS for learning where you could progress students through classes, gathering all this microdata, all these red dots, green dots, etc. You're collecting this all so you can actually create customized learning paths, taking them through one class to another to pursue distant learning goals and objectives in a really, really customized way. And we're not only thinking about going, we're joining classes together at Caltech, we're going beyond Caltech. We're joining K through 12 classrooms, we're joining community colleges. Everyone's got access to everyone's cards, everyone's data, everything's linking together into a giant unified whole, which is fantastic. And the sort of things you might imagine, you're going to break down these silos. Everyone's going to be able to talk to each other. You're going to be able to take all this micro-engagement data, all this micro-assessment data, and bring it together into a unified way to create these sort of learning paths that can really, really be a partner for lifelong learning. not only in one class, not only in one university, but throughout a lifetime. And that's really our ultimate goal.
Thanks,
Yes.
everybody. So, thank you for participating.